Okay, chapter 9.6 is solving right triangles. Essential question of this chapter section is, when you know the lengths of the sides of a right triangle, how can you find the measures of two acute angles? So what you will learn in this chapter is how to use the inverse trigonometric ratios and how to solve right triangles. So let's take a look. Okay, so using inverse trigonometric ratios, identifying angles from a trigonometric ratios, determine which two acute angles has a cosine of a half. Which of the two acute angles has a cosine of 0.5 or 1/2? Okay, so to solve this, we want to find the cosine of each angle. So the cosine of angle A equals, remember cosine is adjacent to A, to angle A, divided by the hypotenuse. Okay, and if I'm going to find the cosine of B, that will be the side adjacent to B over the hypotenuse. All right, so there's our setup. Now all we have to do is substitute the given. So adjacent to A means next to A is the square root of 3 over the hypotenuse 2. Okay, and then if I go cosine B, well, that's going to be adjacent to B. So let me erase this. So adjacent to B is 1 over the hypotenuse 2. I don't need my calculator to answer this question because we got our answer right here, 0.50. Okay, you might not know what the square root of 3 divided by 2 is, but we can just use our calculator and go like this. Square root 3 divide 2, enter, and that's 0.8660. And this is 0.50. So it says determine which of the two acute angles has a cosine of a half. Well, the answer is angle B. Okay, so now you should be able to do problems numbers 3 and 4 in your exercises. Okay, so we're going to do a core concept here before we do the next example. And it's the inverse trigonometric ratio. Let angle A be an acute angle. So angle A is right here. Let me highlight that. Angle A. All right. So that is my acute angle. That is what I call my reference angle. So the inverse tangent, if the tangent of A equals x, then tan to the -1, x, which is read tan inverse of x, equals the measure of angle A. Okay, so if you take the inverse tangent of the side, you get the angle measure. If you take the tangent of the angle, you get the side lengths. It's okay, inverse tangent, inverse sine, inverse cosine. So where does this come from? Well, if I just had an unknown and I take it to the -1 power, doesn't that equal 1 over that same x to the +1? So remember, what you do is when you have a negative exponent, it takes the inverse or the reciprocal of the fraction or number you had before. And that's how we're doing here with trig functions. So inverse of sine, if the sine of angle A is y, then the sine inverse of the side y equals the measure of angle A. So we're just working in reverse and backwards to go from an angle or the sine of inverse of a side to get an angle measure. And then it works for sine, cosine, and tangent. So it says if cosine A equals z, then the cosine inverse of z equals the measure of angle A. And here they have the ratio set up. So the tangent inverse of side BC opposite over hypotenuse AC, or I mean adjacent, opposite over adjacent. So tan inverse of BC over AC equals the measure of angle A. So that's just opposite over adjacent. Sine inverse of BC over AB, which is the opposite over hypotenuse. Sine inverse of the opposite over the hypotenuse will give you angle A. And cosine inverse of the adjacent over hypotenuse will give you the measure of angle A. So let's take a look at an example. All right, example 2, it says find angle measures, finding angle measures. Let angle A, angle B, and angle C be acute angles. Use a calculator to approximate the measures of angle A, angle B, and angle C to the nearest tenth of a degree. Okay, so back in the day before calculators, we used to have what were called trig tables. They're still available. Big Ideas also offers them. You can look at the trig tables, trigonometric ratio tables, if you will. And you look in the columns of the trig table to determine the values. All they've done is calculated it and put it into a table. So here's what we have. We're going to use a calculator. The first thing you want to do is go to mode and make sure you're in degrees. So the first thing you always want to do is make sure your calculator's in degree mode. And I'm going to hit second quit. And let's take a look. And tangent A equals 0.75. So since the tangent of A is 0.75, then what you do is say the measure of angle A equals, and if we go back here, it's the sine inverse of BC over AB. So we're going to say it equals the tan, we're taking tan of this, so this is going to be tan inverse. So what I'm doing is I'm looking at the inverse tangent rule right here. Since we had the tangent of angle A equals some value, then tan inverse will give you the angle measure. So the tangent of A equals 0.75, then the measure of angle A equals the tan inverse of 0.75. Okay? And I'm just going to put that in my calculator. So to get tan inverse, if you look right here, the button tan right here has a blue tan to the -1 above it, which means you use the blue button here and you hit the tangent button. So there's the tan inverse on my screen. And I say 0.75. 0 is optional in front of a decimal. And I hit enter and I get approximately, what's it say? Round to the nearest 10th of a degree. So I go out to the 100th and it's greater than 5. So it gets rounded up to 9. So my answer is the measure of angle A is approximately 36.9 degrees. Okay, pretty simple. Now let's do sine B. So since sine B equals 0.87, I will now say that the measure of angle B equals the sine inverse of 0.87. So the measure of angle B equals sine inverse is second sine, and then you do 0.87 and hit enter. And that's 60.45, 5 rounds the 4 up to a 5. So that is going to be an approximation. So let me get rid of that equal sign. It's approximately 60.5 degrees. Okay, and then finally C, if we have the measure of angle C equal to, since we have cosine C equal to a decimal, then the measure of angle C will equal the cosine inverse of that decimal value. So then I hit second cosine for cosine inverse, 0.15, close parentheses and hit enter. And I get 81.37, which rounds to 81.4. So the measure of angle C is approximately 81.4 degrees. Okay, and that's all there is to it. So now take a look at numbers 8, 10, and 12 in your exercises. Okay, solving right triangles, core concept. Solving a right triangle. To solve a right triangle means to find all unknown side lengths and angle measures. So if it's a right triangle, you only know the right angle is 90 degrees, and they might give you a side or two, and you have to find everything else. So you can solve a right triangle when you know either of the following: 2 side lengths or 1 side length and the measure of 1 acute angle. So you need 2 things: 2 sides or a side and an angle. So let's take a look in the next example. Okay, so solving a right triangle. Solve the right triangle. Remember what that means. Find all side lengths, find all angle measures. We need 2 sides or 1 side and 1 angle measure other than the 90. We need 1 acute angle and 1 side or 2 sides. In this situation, we have 2 sides. So what do? Well, we can find C by doing the Pythagorean theorem. C squared equals A squared plus B squared. Don't know C. A is opposite angle A, that's 3. B is opposite angle B, which is 2. So C squared equals 3 squared plus 2 squared. So C squared equals the square root of 13. Oops, I mean 13. C squared equals 13. I'm getting ahead of myself. 13, and then you take the square root of both sides, like so, and that will give you C equals the square root of 13. So if I get my calculator out, the square root of 13 is approximately 3.6. Okay, so I found the side. That's approximately 3.6. And now we're going to find the measures of the angles. So now let's find B. So the measure of angle B equals, and what I'm going to look at is, the book is showing tangent here. Because you could use sine, you could use cosine, you could use tangent, but remember, this is an approximation and I don't want to use it because then your answer is less accurate. So use the givens 2 and 3. So with respect to B, we have opposite and we have adjacent. So the measure of angle B is going to equal the tan inverse of opposite over adjacent. So I want to find the tan inverse of 2/3. So the measure of angle B is going to be approximately, and then I go to my calculator, second tan for tan inverse, 2 divided by 3, close parentheses, hit enter, round to the nearest tenth, as it says right here. So it's going to be 33.7. 33.7 degrees. Okay, so there's a measure of angle B. Well, now I need to find the measure of angle A. I will do that in blue. Here's the angle A. And again, we have opposite and adjacent. So, or we could do the triangle sum theorem. Yeah, just pause there for a second. We know that's 90. And we know there's a theorem that says that the acute angle theorem of a right triangle says that the two acute angles are complementary or add up to 90 degrees. So I can just simply do this. The measure of angle A equals 90 minus the measure of angle B. So the measure of angle A, and it's an approximation because angle B is an approximation, it's going to be 90 minus 33.7. Okay. And so the measure of angle A is approximately 50 would be 83. So it's 56.3 degrees. Okay. So there's C, measure of angle B, measure of angle A. We knew A, we knew B, we knew angle C. We just solved this right triangle. All right. Now try that on exercises 13 and 14. Okay, example 4. Again, we're going to solve this right triangle, round decimal answers to the nearest tenth. So let me get my highlighter, round to the nearest tenth. And we're solving the right triangle, and H is our reference angle. Okay, so that's the angle we know. So in this situation, we know one angle and we know one side. And when I say one angle, I mean one acute angle. So with respect to angle H, I'm going to say, I know the hypotenuse, so I'm not going to use tangent here. Opposite over hypotenuse is sine. So the sine of angle H equals, I'll just write it this time, opposite over hypotenuse. So the sine of angle H equals the opposite, which is H. Actually, the sine of H, I'm substituting givens now. The sine of 25 degrees equals H over 13. Okay, so there it is. We wrote a formula for sine, substitute the givens, and now we simplify and solve. Well, to get H by itself, I need to multiply by 13. So I'm going to multiply both sides by 13, and these cancel. And that's going to leave me with side H equals 13 times the sine of 25 degrees. Okay, so now I'm going to get an approximation. I'm going to get my calculator out, and I'm going to put 13, and you don't have to hit times, just hit sine. That means 13 times the sine. And I put 25 degrees in and close the parentheses and hit enter. And I got 5.49, which rounds to 5.5. So H is approximately 5.5 units long. So that's H. And now I want to find G. Well, what is G with respect to H? I mean, with angle H. Let me change colors here. So here's angle H. It's 25 degrees. I know adjacent. So I'm going to say adjacent, and I know hypotenuse. So I'm going to use cosine. So the cosine of angle H equals adjacent over hypotenuse. So substitute the givens. The cosine of 25 degrees equals G, which is adjacent, over hypotenuse 13. Multiply both sides by 13, just like I did with sine. These cancel. I get G equals the 13 times the cosine of 25 degrees. It's going to be an approximation. So I'm going to say 13 cosine 25 and hit enter, and I get 11.78, which rounds to 11.8. All right, so let me just erase all this here. So, and then we want to find the measure of angle G. So the measure of angle G equals 90 degrees minus the measure of angle H. Substitute the givens. The measure of angle G equals 90 degrees minus 25 degrees. So the measure of angle G equals 65 degrees. So H is 5.5, G is 11.8, and angle G is 65 degrees. We just solved the triangle. Now take a look at exercises 15 and 17. Okay, so example 5 is a real life problem. It says your school is building a raked stage. Okay, so for starters, this right here, raked stage. That means that the back of the stage is higher than the front of the stage, so it's sloped downward, and it gives the audience a better line of sight. And they say that choreographic moves are more appreciated on a raked stage. So we're dealing with a stage that is sloped from back to front down. Okay, so here is a stage under the lights, and it says the stage will be 30 feet long from front to back. Okay, we're talking about the stage, so that's the top, so that's going to be your hypotenuse. So I drew a triangle here that we can pull out from the diagram so it's less confusing, and I will label it as we go. So this is the right angle. And they said the stage, which is this top part, is 30 feet. You want the rake angle of elevation to be 5 degrees. Okay, that is going to be our reference angle right here. So that is going to be, you want it to be 5 degrees or less for safety. Is the rake stage within your desired range? So we don't know that this is 5 feet. We want to know if it is. So right now I'm just going to do this. I'm going to call that X. So they don't want it steeper than 5 degrees because then it's too steep and it's dangerous. That's what they're saying. So we have one side. Oh, and by the way, the stage back is 2 feet. So I was just going to say we don't have enough information here. We need one angle, one acute angle and a side, or we need 2 sides. And in this situation, we have 2 sides. So we can move forward and solve this triangle. So if I called this A and this B and this C, then I can find the rest. Okay, so the first thing I'm going to do, I could do the Pythagorean theorem and find the side, the length from A to C, but that's not what this question's asking. So we don't have to solve the triangle. We just have to see what angle A is. And with respect to angle A, that's our reference angle. So let me highlight that. With our respect to angle A, we know opposite and hypotenuse. And let me label that. So this is opposite. This is hypotenuse. So that is sine. So I'm going to say the sine of angle A equals opposite over hypotenuse. Okay, so I'm going to substitute in now. X equals 2 over 30. So I want to know what the angle is. So I'm going to say since I don't know the angle, I'm going to take the sine inverse. So x is going to be approximately the sine inverse of 2/30. Okay? So when you don't know the angle side, the inverse of it is the opposite over the hypotenuse. So x is approximately sine inverse divided of 2/30. So I turn my calculator on, second sine for sine inverse. Oh, my calculator turned off, so it automatically goes back to radians. So I need to go to mode. Oh, it didn't. Usually it does. Okay, but it's always good to check. It's still in degrees. Okay. And let's go back here. So I'm taking the sine inverse of, so second sine 2 divide 30, or 1/15, you'd get the same answer. Round to the nearest tenth, you get 3.8. So x is approximately 3.8 degrees. And it says you want the rake to be 5% or less for safety. So 3.8% is less than 5%. So this is a safe stage. Okay, now try exercise 20. Okay, that brings us to the end of chapter 9.6. These are the exercises I asked you to do. Thanks for watching. Have a great day.